Supervised learning on classification. By the end of this lesson, you will be able to explain classification as part of supervised learning, demonstrate the different classification techniques in Python, evaluate the classification models.
So let's go ahead and understand classification in detail. Let's first understand what classification is. It is a machine learning task that identifies the class to which an instance belongs. Classification problems are when you are training a model to predict qualitative target. For example, a news article can be classified based on its features under technology, sports, or entertainment domains, respectively. Let's look at the classification example, which includes training a classifier model with respect to the available data. In the given example, faculty appointments are classified into ranks and groups by year of experience. These classifications have significance with regard to the benefits and rights that may or may not pertain to each category or classification, such as the granting of tenure. The model will classify if the professors are tenured or not based on years. If the number of years is more than 6, then the professor is supposed to be tenured. There can be some unseen data that you can use to validate your algorithm. In turn, your classifier prediction can be validated as well. Let's understand the workflow of classification. In classification, inputs are divided into 2 or more classes, and outputs are discrete. The learner must produce a model that assigns unseen inputs to one or more of these classes. Collect training data. Assemble features that store the known class label and numeric values for the predictors. Instantiate a classifier. Set its parameters if necessary. Train the classifier using the training data. Classify an image using the classifier model for prediction. Estimate classification error with independent validation data. Validate your algorithm with the classifier model and come up with a predicted label. Classification, a supervised learning algorithm. You must be thinking how classification is supervised learning algorithm. Let's understand how classification processes data in order to understand why classification is a supervised learning algorithm. Here, the training data contains labels that are used with feature vectors on which the classification algorithm is applied. The output of the algorithm is predictive model, which is validated against some individual data that has a separate feature vector, and the validation output is the expected label. Since classification algorithms are applied to the dataset that has predefined labels, it shows that classification is a supervised learning algorithm. Let's look at the use cases of classification. The first use case that we will focus on is sentiment analysis. Let's understand how sentiment analysis is a classification algorithm. Sentiment analysis is the computational study of people's opinions, attitudes, and emotions toward an entity. The entity can represent individuals, events, or topics. It identifies the sentiment expressed in a text and then analyzes it. Sentiment analysis can be considered a classification process, as there are 3 main classification levels in sentiment analysis: document level, sentence level, and aspect level sentiment analysis. Document level sentiment analysis aims to classify an opinion document as expressing a positive or negative opinion or sentiment. Sentence level SA aims to classify expressed sentiment in each sentence. Aspect level SA claims to classify the sentiment in comparison with the specific aspects of entities. The second use case that we have is fraud detection. Fraud detection detects the data streams of transactions and learns the fraudulent patterns. A fraud is a small fraction of the daily transactions. Fraud detection is a classification algorithm as it contains information about the account or card holder, such as income, information about large purchase, occupation of cardholder, etc. Classification can be done using these patterns or labels. Classification systems that include optimization techniques, such as genetic algorithm and support vector machine, show a greater fluctuation in the implementation of many different technologies due to the efficiency and accuracy it produces. Let's now look at how face detection is a classification algorithm. Face recognition is a biometric technique used mainly for surveillance purposes, such as searching for suspected terrorists, wanted criminals, and missing children. The term face recognition refers to identifying an unknown face image using computational algorithms. This operation can be performed by comparing the unknown face with the faces stored in database. A successful face recognition methodology depends heavily on the particular choice of the features used by the pattern classifier of classification algorithm. Classification algorithms. Commonly used classification algorithms include decision tree, support vector machines, SVM, random forest, naive Bayes classifier. Decision tree classifier. Decision tree is a tree-based classification algorithm. A decision tree is a flowchart shaped like a tree where every internal node denotes a check on an attribute. Every branch represents an outcome of the test, and every leaf node, terminal node, holds a class label. Classification rules are represented by a path from root to leaf. Here are some common terms that are used with decision trees. Root node. It represents the entire population or sample that further gets divided into two or more equivalent sets. Splitting. A node can be divided into two or more subnodes using splitting. Decision node. When a subnode splits into four subnodes, then it is called a decision node. Leaf terminal node. It is the node that does not split. Pruning. It is the process of removing subnodes from a decision node. Branch, subtree. A subsection of the entire tree is called a branch or subtree. Parent and child node. A node which is divided into subnodes is called a parent node of the subnodes, whereas the subnodes are the children of the parent node. Let's understand the schematic representation of decision tree. Decision trees follow a natural if-then-else construction due to which it easily fits into a programmatic structure. Decision trees are best for a categorization problem where attributes or features are systematically checked to determine a final category. As the goal of a decision tree is to make the optimal choice at the end of each node, it needs an algorithm that is capable of doing just that. Therefore, it uses Hunt's algorithm, which is both greedy and recursive. Purity is the metric according to which a decision tree makes it the decision to split each node. A node is 100% impure when a node is split evenly 50-50, and 100% pure when all of its data belongs to a single class. In order to optimize our model, we need to reach maximum purity and avoid impurity.